Alrighty, friends, let's tackle 12.2. We're going to do arithmetic sequence and series. Yesterday, we talked about sequences in general. That is just a list of numbers that have a math pattern. Arithmetic is a specific kind of pattern. And hang on. What that really means is that you go from term to term by adding or subtracting the same number. So you're going to have your first term. You're going to either add or subtract a common difference, we call it. So these will have what we call a common difference. In our formulas, the common difference will be notated with the letter D, and it's the number you're adding or subtracting to get to the next term. So then here, you're going to add or subtract that same number again, and so on down the line. So there's a couple different ways you can write the explicit rule, and ironically, neither one of these is the one that I like. I do this one, but I put the D in front of the parentheses just because it helps kids remember more often to distribute that number later. So this is just kind of representing the number at the end, or like any term that's in the future. This is going to be, like we learned yesterday, your first term. This is going to be the spaces basically, or like the number of times you used D. So for example, up here, for me to get from 1 to 3, I used that common difference twice. And so that's why it's n minus 1. You're just like saying, where did I end? Where did I start? And how far is there between them? So this is going to basically be the number of times that you use that common difference, or the spaces between. And then this is the common difference. So A1 is going to be my first term. N is going to be the number of terms. Are you looking for the 5th term, the 10th term, and so on? A sub n is going to be kind of like any future term. So if you want to find the 7th term, A sub n is going to be what you write. Any future term, except I just made that up, that word. Like a term that's further down the line. We call it the nth term, like yesterday. And then in these formulas, D is representing that common difference, the number that you are adding or subtracting as you go term to term. How do you find that? Sometimes you can just see it, like you can just say, oh, they're going up by 2. But if you don't, you can take any term in the sequence, subtract the term before it. So the one that's in front of it in the list. And then that will tell you the common difference. So we sometimes, in fancy words, we write it like this, meaning any term, and then the term before that would be n minus 1 in the bottom. You don't actually have to subtract one from it. But you would be saying, oh, here's the first term, here's the second. Somewhere down here is n sub 1. The one after that is n sub n plus 1. Sorry. But the one before it will be a sub n minus 1. So this weird notation we use to say, hey, we're just talking about like the previous term. So let's look at that mathematically. It'll be a lot easier. Decide if it's arithmetic and find a common difference. So to find the common difference, I can take any term and subtract the one before it, and that equals 4. But now it has to be the same. So when I take 15 and subtract the one before it, I have to still get 4. And you could probably just look at this one and not have to do that. You'd be like 7 plus 4 is 11, plus 4 is 15, plus 4 is 19. So the answer is plus 4 is my common difference. So this one is indeed arithmetic. Versus over here, let's see. So you can do a couple things. Here, to get from here to here, I'd have to add 24, but that's not happening on my next one. I'm not adding the same number to get there. If you like to take the term, any term, and subtract the one before it, you'd still get 24. But it has to work for all of them. And when I take 108 and subtract the term before it, it definitely does not equal 24. So this one is a no. It is not arithmetic. How about this one? Well, to get from here to here, I'm taking away 500. Does that hold true here? It does not. If I take 500 away from 125, I'm certainly not going to get 25. So this one is a no as well. It is not arithmetic. So arithmetic is just like a special kind of list that we talked about yesterday. Sequences are all the number patterns. Arithmetic is just adding and subtracting. So here, if you look, some of you will just be able to see, oh, I'm just subtracting 3 each time. Or you can start with a term and subtract the one before it and find out that that's the number. Then you could start with the next term, subtract the one in front of it, and get the same number. And so either way, you can figure out that this one is indeed arithmetic, and the common difference is that you keep subtracting 3. So like if I wanted the next number, I'd subtract 3 and get -7. Then I'd subtract 3 and get -10, and so on. So what we're going to learn how to do is like, how do I write the rule for that? Now the formulas were up here. I'm going to copy the one that I use the most. A sub n is going to equal the first term. Then you're going to add or subtract that common difference, n minus 1 times. So in this sequence they gave me, first of all, I can see by looking at it that the common difference is going up by 3. This is my first term. So when I go to write the explicit rule, I put, this stays as like an unknown, like it's like y equals. You're saying to find any term, take the first term, which is 7, add the common difference, which is 3, and the number of times you're adding it is n minus 1. So you're saying, hey, start here, add 7 once, twice, 3 times, 4 times, and it's n minus 1 because to get from this first, second, third, fourth, fifth, I would have added the common difference once, twice, 3 times, 4 times. So I'm counting the spaces between them. So you're saying, hey, to get any term, take 7, that's where you start, add 3, n minus 1 times. Now this is to always simplify. The simplifying is always the same 2 steps. Distribute that d value. So I'm going to have a sub n equals 7 plus 3n minus 3. And then the second step is always the same, combining the like terms. So the like terms are going to be the numbers. So 7 minus 3 is a plus 4. So this is actually my final answer to the rule that works for those numbers. So here, we're going to find the rule, and then we're going to use it to find the 15th term. So let's do that. Start with my formula. A sub n equals the first term. Now, if you look here, you can see that these are going up by 3 as well. So I'm going to add my common difference, n minus 1 times. Then distribute this number. So that'll be 5 plus 3n minus 3. And so then I'm going to get, when I put the number parts together, 3n, and then 5 minus 3 is 2. So this is my rule. And now I can use my rule to find the 15th number in the term by doing what we learned yesterday and plugging in 15. So if I did this out to the 15th number, it would turn out to be a 47. Let's see what's going on here. If I look at this, I can figure out that these are going down by 8. And so that's my common difference. It's starting at 60. So I start with any term is 60, and in this case it's minus 8 and minus 1 times. So be careful with distributing because you're distributing a negative. So negative 8 times negative 1 is going to be a positive 8. So my explicit rule is negative 8n, and then 60 plus 8 will leave me with 68 because those are both numbers, so they can go together. So that's my explicit rule, but then I can go ahead and find the 15th term by plugging in a 15. And that's just what we did yesterday. And you use your calculator and say, well, the 15th number would be a negative 52. Okay, now this gets a little trickier. It says one term of the sequence is 20, the fourth term. So 1, 2, 3, fourth number is 20. The common difference is 3. So as I'm going along, I'm adding 3. Write a rule. So I don't know the first term, but I do know the fourth term. So what I would do is I would start by saying, hey, to get to the fourth term, I start at the first term. I'm going to add 3 4 minus 1 times, because remember how the formula is n minus 1, and n is this here. Basically, you're saying how many spaces is it to get from the first term to the fourth term? And the answer is it's 1, 2, 3 spaces. So I'm saying, hey, if 20 is my fourth term, but I don't know my first term, but I know I'm adding 3 times, then I end up with just the ability to solve for a1, meaning the first number. And I would think, oh, I must have had an 11 in that first spot. Okay, now that I know the first number is an 11, I'm able to go ahead and write out that equation that we've been using. I can say, all right, I'm going to erase some of my work here. I'll cram it in. A sub n equals the first number that I now know plus the common difference, n minus 1 times. So I had to find that first term. Now, it's kind of a cheaty backwards way. If you're adding 3 to go this way, you're subtracting 3 to go that way. So if you wanted to fill in 20 minus 3 is 17, minus 3 again is 14, minus 3 again is 11. That's another way you can find it. It's just not efficient if you have numbers that are really far apart. But either way, once I know it's 11, I'm going to distribute my 3 and combine my numbers. So that is just for arithmetic. It's like a little formula we can use only when there's a common difference. So yesterday we did listing and adding. Today we're going to do the same thing. When you go and do an arithmetic series, it means you're going to add up the terms. Yesterday we used sigma. This is going to be a shortcut. Remember how you had to find all the terms and then add them together? This is going to be a shortcut, but only if it's an arithmetic problem to begin with. And here's what this is telling me to do. This is telling me I'm going to find the sum of n terms. Notice that these are both n's here and here, so I'll put up at the top the number of terms. And then what's nice about this is all I have to do is find the first number in the list, and then this will be the last number. So if I had like n equals 1 all the way up to, or I shouldn't use that at the bottom, that'll confuse you. Yesterday we did like I equals 1, stop plugging in n, and then here we would have a rule. The only thing is today these have to be arithmetic, and then we can use the shortcut. So the ones they give us are arithmetic. Let's use the formula. Because like here, I do not want to plug in from 1 to 20. So what I'm going to do is use the formula. I'm adding up 20 terms. From 1 to 20 is 20 terms. And I'm going to then use that 20 up here because in the formula both of those are n's. Now all I need is the number I get when I plug in the bottom. So 5 times 1 plus 3 is an 8. And then the only other number I need is going to be, I'm looking at my answer key and or like my filled in notes, and it looks like something's not right. So I have to grab my calculator so I can do the right thing, because oh, my bag is super messy. Hang on, guys. Okay, got it. Now I'm going to find my last term by plugging in the 20. So 5 times 20 plus 3 is going to turn into 103. So I can use the shortcut and I can say, okay, I'm going to be taking 20 divided by 10, or excuse me, 20 divided by 2, which is a 10. Sorry, that's why I said that. And I'm just going to plug this whole thing in my calculator. So you can kind of do it however you want. You can do 8 plus 103 first because it's inside, and then you can times that by 20 over 2, which is 10. But when you're done, you're going to have 1,110. Okay, so over here, I'm going to start with a sub 3 and go all the way up to the 10th term. I'm not starting at 1. So from the 3rd term to the 10th is actually going to be 8 terms because I would have a sub 3, 4, 5, 6, 7, 8, 9, 10. So I'm adding up 8 numbers. If I had to plug numbers in, I'd plug in 3 and then 4 and then 5 and then 6. So I'm going to end up with sum of 8 terms. I'm going to be using 8 up here because these two always match. I need my first term, but my first term is what you get when you plug in this bottom number. So 18 minus 3 times 3 turns out to be a 9. And then I'm going to add the last term, which is going to be 18 minus 3 times 10, because that's the last number I would plug in. So that's going to be a negative 12. So if I put this into my calculator, 8 over 2 is a 4, and 9 minus 12 inside is a negative 3. So I end up with negative 12. So I'm just using the formula. All right, this is the tricky business, and this is the last thing we're going to do. We're going to determine the number of terms and then find the sum. So this can be kind of tricky because this is A1. This is A sub n. I don't know because this right here means I don't know how many numbers there are. I can see by looking here that my common difference is 5. So when I use my formula, A sub n, which I don't know, actually that's not true, I do know it's 150, sorry, is going to equal my first term, which is 5, plus my common difference, which is also 5 from up here. And then we always do n minus 1 times. Well, I don't know how many terms there are, so I leave that as n minus 1. Now I'm just going to solve like it's algebra 1. So I'm going to distribute that 5. And then I'm going to end up with 150 equals, these will cancel, 5n. So there are 150 divided by 5 is going to be 30 terms. Okay. Now I know I can go ahead and add up those 30 terms. This part's actually easy. 30 over 2. The first number in the list is a 5, and the last number in the list is a 150. And so I'm going to end up with 5 plus 150, which is 155, times 30 over 2. So if I did find and add up all 30 of the numbers, I'd get 2,325. So there's a lot of steps to that because I didn't have what I needed for the formula and to add them up. So when you don't have what you need, you have to go back to this formula to find it. Let's try that one more time and we'll be done. So if I was going to use my sum formula, the thing I don't know is how many I'm adding up. So I know the first term's 3, and I know the last term's 143, but I don't know how many there are. So I have to go back to this formula to find it. So I'm going to have this formula to find that n, so I can put it here and here. So let's put in what we know. Do we know the last term? Yes, 143. Do we know the first term? Yes, it's 3. Do we know the common difference? Well, if I look, I can see that the numbers are going up by 7. So now I know everything but n, and I can use algebra 1 to solve. Is it a lot of steps? For sure, but this is truly just solving from way back when. I'm going to have a 3 minus 7, so negative 4. Add that to the other side. I'm still just algebra 1ing. I have 147 equals 7n. And when I divide that by 7, I get that there are 21 terms. So whatever this mystery thing is, total of 21. So I'll be adding up 21 terms, throw a 21 in there, and then just do my math. 3 plus 143, I'm doing that first because it's in parentheses. This is 146, and then I can times it by 21 over 2. So if I were to find the rest of the terms, all 21 of them, and add them up, I would get 1533 as the sum of those 21 terms. It's not easy because you got to use your formulas, but there's only 2 formulas. We have this one, which is for adding them up, and we have this one at the very beginning. Well, I guess I'll just show you the way I write it down here. This is the one that helps you find everything else. So the only time I'm using this one is if I'm going to go add them up and find the sum. Every other thing that's arithmetic, I'm using this formula. Hope that helps, my friends. Bye.